typical applications for this I mentioned earlier. If you are in a district heating or cooling area, potentially in a group of hospitals in a metropolitan area, if you're on a college campus, any heating or cooling of that nature. Any energy transfer stations where the heating or cooling fluid from the main plant must go through a heat exchanger at the building entrance, or any of those situations, or any air handlers or air handling units or fan coil units. The next slide is going to actually show you just a simple primary system where the supply, in this case, let's say if it's a chilled water, would actually go through the heat exchanger. It will come back to the pressure-independent control valves and back to the return header. That's kind of a simple graphic, but the next slide will be a little more typical if you had a multiple site situation where you have multiple buildings. There's building A, building B, and building C. You have different air handler units in each one, and in this case you would install these on the outlet of the air handling unit of each one of those. And then there's also one coming out of the final heat exchanger that goes back to the return. The ultimate goal here is to save energy, and I think this next chart gives you an indication of a typical control valve would be the red line here. It would be modulating all over the place, trying to handle these wide swinging loads that potentially can happen in a HVAC application. Your desired set point is up here, your delta T, differential temperature, and you can see the pressure-independent control valve package from Warren works much closer and is much more balanced to that desired differential temperature. Again, it's a bit of a complex application, but I think it's an ingenious concept that they came up with. And if that is your area of expertise, I think it'd be worth taking a look at. Okay, that concludes the main part of our agenda. I do want to advise you that we have a new product catalog that's come out in the last couple months. This is what the front cover looks like on the left. We have a wide variety of items here, all the way from combustion to flow meters to HVAC controls, PLCs, pressure gauges, thermometers, valves, wireless devices. It is probably one of the most complete industrial product catalogs you will ever find. And just out to the right here is just the industrial valve section alone, which is kind of what I was involved with there. We have a pretty complete offering there as far as selection and things like that. If you will go to our website, you can register to have one of these catalogs. By the way, this catalog is almost 1,200 pages. It's quite large, and if you register at the website, you can have one sent to you. You also can look at the entire catalog online if you'd like. You can click on any area. You actually can open up the pages. You can view it online. So please go to our website, check this out, and see if you can get one of these, have these catalogs sent to you. It's a real resource tool that will help you in your position. No question about it. Okay. In review, the automated valves certainly have an initial cost, and sometimes it's a substantial initial cost. I do think there's a large future return on your investment from the standpoint that leaking valves are big energy wasters. When you have an automated valve, you can control a valve that you may or may not know is leaking. The fact that the valves can be opened and controlled remotely is a big plus. The valve position being either open or closed can be verified. The fact that you can test your valves automatically to verify that they're functioning properly, I think is a big plus. And the fact that you could actually sense the valve leakage remotely, I think is certainly a big plus to controlling your energy costs. So in the final thought here is that there's a lot of new technologies out there, and And the exciting part about this is that they offer a very wide opportunity to save energy costs. We're all in this business to gain efficiency and maximize our return and to do the best we can in our jobs, and that's keeping our plants running most efficiently with the best production and the lowest cost. So technology's there. It's just a matter of let's share some ideas and let's open this up. And if you have any questions, please submit them or contact us.
Okay. Thank you, Larry. At this time, I'll read some of the questions that we've received. We did receive a question from Bob. He asks, do you see wireless communications being used more in automated valves and control valves?
Actually, that is probably might be the hottest new market that's coming out there. Some of the largest control valve manufacturers right now are developing and have developed wireless packages within the smart positioners. I mentioned earlier about the digital smart positioners. These smart positioners or smart controllers now can actually tell you the complete health of your control valves. They will look at all facets of it. When the control valve is running, modulating, it is basically data logging a lot of facts, and it's sending all that information back remotely to a control room or to a diagnostic area where it can tell you the health of your control valves. Now, you might say, well, that's just a lot of data that you don't need. Well, the reality is when we schedule these outages and schedule our maintenance times to work on these valves, sometimes these valves get repaired just because, well, it's been 2 years since we've taken a look inside that valve. Let's go do that. So the reality is if you know all that information ahead of time, you're going to know whether that valve needs to be worked on or not. So you're certainly going to save a lot of cost there of tearing a valve out of line and having it repaired when it didn't even need to be repaired. Or you're going to find out you've got a valve that's not performing well at all, and it's a real headache. And if it's a case where every 6 months you're finding this valve failing, well, then you need to look at maybe a different valve for that application. It's being misapplied. So, yes, wireless communications are gaining in popularity. The technology is improved so much in that area. And by the way, for those of you out there that think that it's not a secure mode to actually transfer data, this day and age, the security is very, very high on this. They use a lot of different codes and everything to actually keep that data secure. And there's mesh networks set up so that data is assured of getting back to the diagnostic area. So yes, wireless. We could do an entire seminar on just wireless technology within the valve industry right now. It's growing dramatically.
Okay, thank you. We received another question in from Chris. He asks, what is the best type of isolation valve to install upstream of the control valve?
Okay, you saw my slides there. There was 2 valves in that one tandem situation there. There was a manual gate valve, and then there was a ball valve. Whenever you have a control valve, typically they ask for pretty much like a flow meter. There's so many pipe diameters upstream and so many downstream, the straight pipe. Control valve does not like to have a lot of turbulence coming in the front side of it because it makes it harder for it to control properly. So my point there is you would not want to put another restrictive type of valve right in front of the control valve, such as another globe valve, because that would potentially cause problems. So you'd want as much of a full flow type of valve as you could. So a gate valve is virtually almost a full port valve, and a ball valve in many cases is close to full port. So I would think either one of those choices would be a good idea. So the least restrictive valve you could get that still would offer a tight shutoff.
Okay, thanks. We received another question in from Tom, and he says, I'm confused about the terms boiler blowdown versus boiler blow off. What is the difference? Okay,
that's a good question. Thanks for asking that. Actually, sometimes those terms get interused and switched around. And in reality, I've read articles in many many situations where they can be used both ways. But the typical way that the engineering manufacturers term them, the blowdown is what we talked about. That's where you're pulling what they call like skimming the impurities off the top of the boiler feed water. Blow off is the other side of the boiler, which is the bottom part of the boiler, where what they call the mud leg is on the bottom of the boiler, and that's where all the sediment and all the dissolved solids and the sludge that happens within boiler water, it falls down to the bottom. And there's a special set of blow-off valves that are installed down there. And those are opened up to get all that sludge out of the bottom of the boiler. And those can be done sometimes. They're rarely ever done on an automated basis. They're done manually, and they are done maybe twice a day, once a day, 3 to 4 times a week, something like that. So blow off is typically the bottom part of the boiler, where they remove the sludge and the mud, and then the blow down is what's taken off the top of the drum boiler.
Okay, thanks. So we seem to be out of time today. If you missed any part of today's presentation, we will post a recorded version on our website, which is industrialcontrolsonline.com. And within the next couple of days, we will email a link to the video and our contact information if you have any further questions or feedback for any of our future webinars. And we thank you for attending, and we look forward to having you back soon. Thanks a lot.